Move to our next presenter, Daniel Hristovski from North Macedonia. Daniel, please. I would also like to mention that Daniel won the bronze medal. Daniel?
Yeah, I did.
To the latest Balkan Physics Olympiad.
I'm Daniel Hristovski, and today I'll be presenting something that's not really connected with quantum physics, but rather the topic of electromagnetism in physics. The title is Lorenz's Force, Ocean's Course, Acyclic MHD Thrusters, Unmatched Source. That should be good now. So firstly, I will be talking what is magnetohydrodynamics as a topic of physics. What principle does it work according to? What led to this phenomenon? When did this phenomenon got firstly introduced? An overview of our work, how it was constructed, and is it used worldwide, as well as its advantages and disadvantages. So firstly, what is magnetohydrodynamics? Magnetohydrodynamics is a science that studies the dynamics of electrically conductive fluids, e.g. salt water, liquid iron, plasma, etc. Anything that contains ions within its fluid. The word magnetohydrodynamics is composed of three parts: magneto meaning magnetic, hydro meaning water, or rather fluid, and dynamics meaning motion. A basic concept of magnetohydrodynamics is that magnetic fields can induce currents within the fluids and lead to an interesting interaction, creating forces within those fluids. The fundamental force that is in this topic, it's the Lorentz force. So the Lorentz force, it's a basic force in electromagnetism, and it acts on charges moving at a certain speed. It requires a magnetic field to exist, and it's given by the formula Q times V times B times the sine of the angle alpha. Q is the charge of the particle, V is velocity, and B is the magnetic induction of the local field. And we can do a simple substitution for Q times V, where we take the time from the velocity and add it to the charge. And we know that current is defined as the amount of charge traveling through a certain area in a given time. And we will get the formula F that is equal to B times I times L times sine of alpha. This is just an animation of the Lorentz force, where we have the interaction of the magnetic field and the current, and we get the Lorentz force being produced. Now, the beginnings of magnetohydrodynamics are pretty interesting. Firstly, it was defined in a science journal in 1942 that was entitled "The Existence of Electromagnetic Hydrodynamic Waves." In a later edition, shortened the term to just magnetohydrodynamic waves. Now, there were more scientists beginning to explore this area, and a lot of people took interest in how to make use of this in thrusters. How do we make thrusters using this force for the sea travel or air travel? So, firstly, there was a prototype in 1966 where Professor Stuart Way built a 3-meter-long submarine that reached a maximum speed of 0.4 meters per second. Then a later improvement by the Japanese, which was of length 3.6 and reached a speed of 0.6 meters. And in 1991, the most significant and latest contribution was made, where there was a complete submarine built that carried a crew of 10 at a speed of 4.2 meters per second. Ion wind, the precursor of MHD, is the very idea that sparked the discussion on MHD. So ion wind is studied by electrofluid dynamics. That is just a sub-study of MHD, and it just depends on the current. Now, there are there is two steps on making ion wind. So we need two electrodes, one thin and one thicker, to direct the air. Charges accumulate most on sharp surfaces, so the thin electrode will be at a very high voltage, about 20 kilovolts. At that voltage, the air closest to the thin electrode begins to ionize, and in the dark we can see the light around the thin electrode, which is actually plasma or ionized air. So as we know from the Frank Hertz experiment, we are able to actually excite electrons and get some light. Ions whose charge is the same as the charge accumulated on the thin electrode are repelled upwards, creating a wind of ions that would move a structure upwards. Now, our prototype. We tested how we can bring this effect to submarines and most effectively eliminate noise pollution in the oceans. So, the part of electromagnetism is relatively little studied in schools. That is, the students' knowledge is not deepened. In doing so, they surf the net quite actively and come across unknown and unlearned terms and phenomena. So our idea is a mixture of both. To learn more about something, you can't just sit and read a book or look at a video. It has to be interesting. It has to mean something to you. So that's why we created a project on MHD, which is inspired by project-based learning, which is very, very popular abroad in the European Union and America. Design. Coming across an example from YouTube, we used our existing knowledge of physics and designed a motor that did live up to our theoretical expectations. So here is a quick time-lapse of a 3D printing process. We used the 3D printer as it was the most suitable to create our prototype in the least amount of time and give us the best results. Now here is the demonstration. We use just food coloring to make the flow visible. There are 2 electrodes present, as well as 8 neodymium magnets that are able to generate the necessary components to create the Lorentz force. Now, is magnetohydrodynamics used in the world? Or if it is, where it is used? Sadly, nowhere. It is currently not used because this phenomenon has not been sufficiently researched. Theoretically, this phenomenon could also be used in space as part of the later stages of a rocket. Recently, in January of this year, a press release was made in a conference in which they explained their idea for a working rocket engine prototype by 2030. Now, the advantages. It's good that we have like a theoretical basis for this phenomena, but why would they actually use it over standard propellers or rockets with hydrogen and oxygen fossil fuels? So, firstly, the main advantage is actually elimination of noise pollution. So, if this technology is used in sea-based vehicles, it could just eliminate noise pollution as a whole. Propellers, due to their movement and vibrations, are actually generating a lot of noise pollution, which is detrimental to sea life. Now, another advantage is because this type of engine has no moving parts and it is able to generate thrust and rival propellers, it also makes construction of many vehicles easier, as well as it is also very easy to maintain because, again, no moving structures. And since this area of physics studies conducting fluids, this engine, again, could be used in rockets by using plasma as the main conducting fluid instead of seawater like in sea-based vehicles. Now, the main disadvantages during our testing of real-world scenarios, the most basic drawback was the presence of corrosion on the plates themselves. Due to some byproducts of half reactions in chemistry, we were not able to achieve 100% efficiency. Now, this can be very easily solved by using stainless steel plates, which are less resistant to corrosion, but still wouldn't achieve that 100% efficiency. The large magnetic field required for the motor to gain sufficient power is still a drawback, because who can create a magnetic field that easily, except CERN. The large current required, again, due to the direct proportionality of the engine to the current supplied, is, again, a drawback. Again, CERN has already achieved this by making superconducting materials, and that was not possible for us. and the large presence of ohmic heating. Ohmic heating is not talked about that much, and it's a type of heating that occurs at the power unit. Because of the low resistance of the circuit, most of the power is drawn and is used on the power unit itself. And so, in the absence of resistance, the motor and in general the electric circuit is overheated. That would be all from me.